what do we know for sure? Well, we know that there are a number of signals that come both through the brain and through the body, and more likely both, in order to control the onset of puberty in females. A couple of examples. The first is a mechanistic one. We know, for instance, that the entire process of the ovulatory and menstrual cycle is initiated from the brain. We're going to get into this in a lot more detail in a few minutes, but there's a certain number of hormones and neurotransmitters that are communicated from the brain, a structure called the hypothalamus, which roughly sits above the roof of your mouth, and that communicates with a gland, an endocrine or hormone-releasing gland called the pituitary gland. The pituitary gland looks like a stalk that essentially extends out of the brain. It's also located not far from the roof of your mouth, and that has two sort of small marble or grape-sized protrusions, the anterior pituitary and the posterior pituitary, and they release different hormones into the bloodstream. Puberty is in part controlled by the fact that up until puberty, there are neurons in the hypothalamus that release a neurotransmitter called GABA, which is inhibitory, and that prevents the neurons in the hypothalamus from releasing a very important hormone called gonadotropin-releasing hormone, or GnRH. So the first thing I'd really like everyone to know and commit to memory today is very easy. GnRH stands for gonadotropin-releasing hormone. This comes from the brain and will communicate to the pituitary to release certain hormones. Prior to puberty, in both males and females, there are neurons in the brain that are actively suppressing the neurons that release GnRH. It's like no puberty, no puberty, no puberty. Can't have puberty, can't have puberty. And in fact, those cells are releasing this neurotransmitter called GABA because it's inhibitory. It prevents the firing of those neurons. Okay, so puberty is actively suppressed up until a certain point. It's also actively suppressed, at least in some species, and we think at least partially in humans, by the tonic release. That means the ongoing release around the clock of a hormone called melatonin. Later in life, in fact, after puberty, melatonin will be secreted only in the dark phase of each night and around the time that one goes to sleep. But in children, and in particular in children prior to puberty, melatonin is released more or less constantly. Now, melatonin isn't the only source of suppression of puberty. It's also these neural mechanisms involving GABA, but it is certainly a great candidate for one of the reasons why puberty doesn't generally tend to happen at, say, age 4 or age 5. That would be very unusual. Another component of suppression of puberty is that typically in children, they have relatively low body fat stores. Why is this important? Well, we know that one of the things that can trigger the onset of puberty, in particular in females, is that when enough body fat accumulates, that body fat releases a hormone called leptin. And that hormone leptin travels in the bloodstream across the blood-brain barrier and goes to the hypothalamus and can trigger the onset of puberty by activating the neurons that release gonadotropin-releasing hormone. So many people believe that one of the reasons that puberty is happening earlier and earlier in females is because of the accumulation of more body fat at younger ages than was observed 30 or 40 and certainly 100 years ago. Now, I can already imagine a number of people are thinking, oh, this must relate to the obesity crisis. And indeed, there is a crisis of obesity. Obesity is something that is causing all sorts of problems with people's health at various levels, brain and body, and that is far more frequent today than it was even 20 years ago. So it is indeed a crisis because it has enormous detrimental effects for so many aspects of brain and body health and longevity. But this whole process of thinking about body fat signaling leptin to the hypothalamus and the onset of puberty doesn't necessarily have to do with the obesity crisis. It might relate, but it could also relate to, for instance, improved nutrition, which is allowing body fat stores to accumulate, maybe not to the level of obesity, but to accumulate earlier and at younger ages in females, which is then causing earlier puberty in females. To just highlight how that might be possible, I want to review some data that talk about the onset of menses, menstruation, that is puberty, in females according to country and according to age over the last 100 or more years. So what are the general trends in terms of the onset of puberty in females? Well, that's an easy one to answer. Over the last 100 years or so, the onset of puberty has been occurring much earlier with each passing decade. It's really an incredible set of statistics. I will provide a link to these data since I know a number of you are listening and not just watching on YouTube. This is from a study in which the onset of puberty has been analyzed from as early as the 1850s, right? In certain countries, there are data on that, out to the 1970s, and in other countries starting at about 1900, extending out to about 1990. These are ongoing collections of data, but just to give you a sense of how the data are falling out in a couple of different countries, just to give you a flavor. But for those of you listening and for those of you watching, the essence of all of these findings is that puberty is happening much, much earlier with each passing decade. So for instance, in the United States, around 1900 or 1903, the average age of menarche, the onset of puberty in females, was about 14 years old, whereas in 1990, the average age is 11. So that's a pretty significant, we can say, acceleration of the onset of puberty. Now, of course, these are averages, so there will be exceptions. There's a distribution of data. Today, still, there will be young females who will undergo puberty at age 11 or 10 or maybe even 9, and others who will undergo puberty at age 13, 14, maybe even 16 or 17. However, if we look at, for instance, the data from Norway, which dates back quite far, they have excellent record keeping to 1850, what we see is that the average age of the onset of female puberty in 1850 in Norway was 17 years old, whereas in 1970, it's 13 years old. So this is a dramatic acceleration of the onset of puberty. And you see a similar trend in other countries as well. So if we were to look in, for instance, in the UK, they have a smaller data set, meaning it only extends back to about 1940. But the average age of the onset of puberty in the UK in 1940 was 13 and a half years old. Again, this is just for females. And in 1970, it was closer to 13 with a trend towards declining even further. Unfortunately, they didn't continue to collect data out to 2022. And as a final point, if we were to look at, for instance, in Germany and Finland, the average onset of puberty in 1870 was 16 and a half years old. By 1940, was down to 13 and a half years old. So all of these data have borne out over and over again, regardless of location in the world, which is important because when you start to think about the obesity crisis, you could say, well, that's mainly in developed countries, believe it or not, or perhaps not surprisingly. And maybe it has to do with the obesity crisis. And yet, I don't think we can conclude that at all. Something is happening, however. It could be increased body fat stores due to overeating and obesity. However, it could also be unrelated to obesity. It could be, for instance, improved nutrition and the availability of quality nutrition, which can signal the maturation of the brain and body mechanisms that trigger the onset of puberty, ovulatory cycle, and menstruation. So we want to be very careful about leaping to conclusions about what these trends mean, but the trends themselves are very, very apparent. And as a final point, I should also mention that there are a number of different behavioral and psychosocial, as they're called, interactions that can influence puberty as well. This has been most strikingly observed in animals. And so I don't want anyone to be alarmed or to leap to any great conclusions about the onset of timing of puberty in humans, but I'd be remiss if I didn't tell you about a certain result which shows that if a young female is exposed to the odor, not necessarily the pheromones, right? There's a distinction between odors that we perceive and pheromones which are subconscious, right? That we don't actively perceive, but that can impact our biology. And pheromone effects in humans are very controversial. But we know, for instance, that if you take a female animal, and there's some evidence from humans that if you take a young prepubertal female and you expose her to the scent of a reproductively competent male for a series of days, but maybe even as short as a few hours, and she is also not regularly being exposed to the scent of her father, that she can undergo puberty earlier. That's right. There is something about the odor and or pheromones, or perhaps something else, that occurs when a young prepubertal female has a father that she's in regular contact with. He wouldn't necessarily have to live at home, but that is around a lot, that his smell, is registered by her biological systems, that I don't want to say protects because it kind of skews the valence of the conversation, but that offsets or buffers the otherwise observed effect